Have you ever dreamed of a flying car, a hoverboard that actually hovers, or even just effortlessly floating up to the top floor of a building? For decades, science fiction has painted a picture of a future where we've conquered gravity, bending it to our will with something called anti-gravity. But here we are, still very much stuck to the ground. So what's the deal? Why, with all our incredible scientific advancements, haven't we found anti-gravity? Is it even a real thing? Let's dive into the fascinating reasons why this futuristic dream remains just that. A dream. First, we need to understand what we're up against. Gravity itself. We all learn about it in school. What goes up must come down. But what is it really? Albert Einstein gave us the best explanation so far with his theory of general relativity. Imagine a giant, stretchy rubber sheet. That's space-time. Now, place a heavy bowling ball in the middle. The sheet curves and dips around the ball. That's what massive objects like planets and stars do to space-time. They warp it. Gravity isn't a force pulling us down. It's us following the curve in space-time created by Earth's mass. This is a crucial point. Gravity isn't a force like magnetism. It's a fundamental property of the universe's geometry. This brings us to our first major hurdle. To create anti-gravity, you'd need to do one of two things. Either create something that repels space-time, pushing it upwards instead of pulling it down, or find a way to flatten the curve that Earth makes. To repel space-time, you'd need something with negative mass. Think about it. Positive mass, like you and me and everything we know, creates a downward curve in space-time. Logically, negative mass would create an upward curve, a sort of gravity hill that would push things away. The problem? We have never, ever observed anything with negative mass. It's purely theoretical. It might exist in some exotic corner of the universe, but we have absolutely no evidence for it. Creating it in a lab is beyond anything we can currently imagine. Now, let's look at the other fundamental forces of nature. Electromagnetism, the strong nuclear force, and the weak nuclear force. For electromagnetism, we have positive and negative charges. Like charges repel and opposite charges attract. This duality is what allows us to manipulate it so effectively. The strong and weak forces that hold atoms together also have their own complex dualities. But gravity? It seems to be a one-way street. It only attracts. There's no negative gravity particle or charge that we've ever found. Every single particle we've ever discovered, even antimatter, has positive mass and therefore attractive gravity. Yes, you heard that right. Antimatter doesn't create anti-gravity. It falls down just like regular matter. This lack of a repulsive counterpart is a huge reason why anti-gravity remains elusive. So if creating negative mass is a no-go, what about other ideas? People have proposed using powerful electromagnetic fields or spinning superconductors to somehow shield or negate gravity. Many experiments have been conducted, often with sensational claims. You might have heard of Eugene Podkletnov, a Russian scientist who in the 90s claimed his spinning superconducting disc could reduce the weight of objects placed above it. These claims generated a ton of excitement, and even NASA tried to replicate the results. Unfortunately, nobody, including NASA, could reproduce the effect consistently. Most scientists now believe the original results were likely due to experimental errors or other known physical effects, like air currents. The dream of a gravity shield fizzled out. The issue here is the sheer weakness of gravity compared to other forces. It might not feel weak when you're trying to climb a flight of stairs, but on a cosmic scale, it's incredibly feeble. The electromagnetic force holding a tiny magnet to your fridge is trillions of times stronger than the entire gravitational pull of the Earth on that same magnet. To overcome or manipulate gravity, you would need an unimaginable amount of energy or some completely new physics that we do not yet understand. The energy required to create a noticeable anti-gravity effect with known physics would be astronomical, far beyond anything we can currently generate. This leads us to the frontier of physics. Perhaps our current understanding, even Einstein's general relativity, is incomplete. Scientists are working on a theory of everything that would unite gravity with the other forces under one single framework. This is the holy grail of modern physics. If such a theory is found, it might reveal new particles or new dimensions that could interact with gravity in ways we can't predict. For instance, some theories, like string theory, propose the existence of a particle called the graviton, which would carry the force of gravity. If we could find a way to manipulate gravitons, maybe we could manipulate gravity itself. But right now, the graviton is as theoretical as negative mass. We haven't found one yet, and we might not for a very long time. Another mind-bending idea comes from cosmology. Scientists have observed that the expansion of the universe is accelerating. To explain this, they've proposed the existence of dark energy, a mysterious, repulsive force that's pushing galaxies apart and counteracting gravity on a cosmic scale. Could this be a form of anti-gravity? In a way, yes. It's a repulsive force that works against gravity. However, dark energy is spread out incredibly thinly across the vast emptiness of space. Its effect is only noticeable over millions of light years. Trying to concentrate enough dark energy in a small space to lift a car off the ground would be, for all practical purposes, impossible with our current knowledge. We don't even know what dark energy is, let alone how to bottle it. So where does that leave us? Are we doomed to be earthbound forever? Not necessarily. While anti-gravity, in the sci-fi sense of a simple on-off switch for gravity, seems unlikely based on what we know, we are getting better at brute forcing our way around it. We don't have anti-gravity cars, but we have helicopters and rockets. We push against gravity with force. We can create powerful magnetic fields to levitate trains. These aren't true anti-gravity, but they achieve a similar result. Future breakthroughs in propulsion, material science, and energy generation could make flying vehicles much more common and efficient, giving us the feeling of an anti-gravity future without actually breaking the laws of physics as we know them. In the end, the search for anti-gravity isn't a failure. It's a testament to the profound and stubborn nature of one of the universe's most fundamental rules. Gravity is woven into the very fabric of space-time. Undoing it would mean undoing the universe as we know it. While we may never have a device that simply makes things float, the quest pushes us to explore the deepest mysteries of physics, from negative mass and extra dimensions to the nature of dark energy. And who knows, in that quest for a theory of everything, we might just stumble upon something even more incredible than anti-gravity. The universe is a strange and wonderful place, and the biggest discoveries are often the ones we least expect. Thank you so much for watching. What do you think? Will we ever find a way to truly control gravity? Let me know your thoughts in the comments below. And if you enjoyed this journey into the mysteries of physics, don't forget to like this video and subscribe for more content. See you next time.